Electricity is always moving. You can understand this concept better by thinking of the flow of electricity through a wire as the flow of water through a pipe. Current in an electrical system is like the total volume of water flowing past a point in a given time. Water flow is measured in gallons per minute, while electric current is measured in amperes. The technical term for the unit of measure for electrical power is coulombs per second. Unless you are an electrician, you have probably never heard the word coulomb. Electricians refer to a current flow of 1 coulomb per second as simply 1 ampere or 1 amp. 1 ampere is the movement of approximately 6.28 billion electrons per second. Voltage is like the water pressure in a pipe. Water pressure is measured in pounds per square inch, while the pressure of an electric current is measured in volts. The need for different voltage circuits arises from the required power supply for components, the distances the electric power must travel, and the known voltage drop that will occur through the wire over that distance. A voltage drop is caused by the resistance of the wire material. A small amount of the voltage is used up, overcoming this resistance when it travels through the wire. For example, a flashlight battery produces 1.5 volts. Virtually no voltage is lost since the bulb is directly touching the power supply, and the bulb does not require much electric power to be lit. An automobile battery produces 12 volts. It supplies more components with power, and that power must travel a short length of wire before reaching them. House and office wiring use 120 and 240 volt circuits. These circuits usually serve electric motors, such as those found in washers, dryers, refrigerators, and dishwashers. Such appliances require more power to work efficiently, as do the lighting circuits of a house or office. Industrial facilities require even more power to run equipment and tools. It is not unusual to see an electric substation outside a large industrial facility. Electric power transmitted over high voltage lines for industry and whole communities can range from 2,400 volts for short distances to more than 500,000 volts for long distances. You can see how the amount of power needed to supply different components and the distances the power must travel establish different voltage requirements for a given circuit. Electricity will follow any path that provides a continuous loop from a voltage source to some point and back to the source. The loop must consist of an electrically conductive material. In fact, your body can become part of a circuit loop. When you come into contact with an energized electric component, you become part of the circuit and become a conductor of electricity. You become part of the loop when you are between two conductors or wires of a circuit, or between one of the conductors and ground. Normally, the path to ground is the path of less resistance, which in this case would be you. The effects of an electric shock can range from unpleasant to deadly.